in this episode what is a subset, proper subset, and a superset. Coming up, back into action. Hey guys, today I would like to give you the idea of a subset and also to relate it to this term, a proper subset and a superset. Let's get into this. Let's say you are given set A, and typically sets are represented by any enclosed figure such as a circle or oval. So, and let's say your set A is made of the following elements. Let's say 0, 1, and let me throw in 2. Now, let's say you are given set B, which is kind of larger than set A, and set B is composed of these elements 0, 1, 2, and on top of this B is made of, let's say 3, 4, and I'm going to throw in 5. Let's write it out explicitly using a roster method, sometimes it's called, or a tabular method. So your set A is made of 0, 1, and 2, and your set B containing the following elements. So 0, 1, 2, 3, 4, and 5. Now, as you can see, the elements 0, 1, and 2, they are also in a set B. So we have these elements here as well, 0, 1, and 2. So A is a kind of a part of the set B. So A is a kind of a set that kind of inside of a set B. So we can say in this case that A is a subset of a set B. So you could think of A as a set which is kind of smaller than set B, and each element of a set A is an element of a set B. That's the important thing that allows us to distinguish, to define the subset. And in this case, we would write just A, and we would use this symbol, which is basically called a subset. So it's kind of sideways letter U, but kind of lying on one side with a kind of a small bar underneath. So that symbol is taken to mean a subset. So again, by definition, each element of A is an element of set B. So, and this is symbol for subset. Notice that there are elements in B, for instance 4 and 5, which are not in a set A. So basically all that means that your set B is kind of bigger than the set A, and A is kind of smaller. It's not that mathematical precise definition, that's why I put it in kind of inverted commas, but just in order to get into this better. Or when it comes to a graphical representation of a set and a subset, so your subset is going to be a circle which is gonna be, or any oval, any closed shape that's gonna be inside of a larger one. Now, with this regard, set B is called a superset of a set A. And also, it also says that B contains A, or a set B includes A. So, in the same vein, you would say that a set A is included in B. Same notation can be just written in the reverse order. Sometimes it's written this way. So B, and all you need to do is just reverse this symbol of inclusion. This is inclusion symbol. And you would write A over here. So in this, from that perspective of view, you would say that B contains A, or B includes A. So A is included in B. Alright, let's take a look at a couple of examples. Let's say you are given set C, and C is made of the following elements: 1, 2, 3, and so on, blah blah blah. So we go on forever. And let's say you are given set D, which is composed of the following elements: So, as you can see, that C basically is a part of a set D. So if I just kind of close these elements, you would see that if we go to the right side, to that direction, we would see these elements. So we would see 1, we will meet them, 1, 2, 3, and so on. So 1, 2, 3, blah blah blah. So besides this part. So obviously that your set C is a part, so is a set which is smaller than a set D. So we can conclude that set C is a subset of a set D. So in fact, if you look carefully, set C is just a set of all natural numbers that normally denoted by symbol capital N, or sometimes it's just kind of bolded N. And also, if you look carefully at set D, you might notice that D is just a set of whole integer numbers. So integer numbers in math, it's numbers kinda 1, 2, blah blah blah, etc. Also including 0 and throwing in the negative. So -1, -2, and so on. Both of them are infinite numbers, so you will never find the last number. It doesn't exist, the last number. So here also there is no kind of first number. So both sets are infinite sets. And for set D, typically it's denoted by capital Z letter, like this, or sometimes it's kind of bolded Z, which stands for a set of all integer numbers. And in this case, you would just simply write that Z, it's the same thing as a subset, or Z is included in set D, and you would use this notation. Or set D or set Z, a set of integer numbers, is a superset of a set N, of a set of all natural or counting, sometimes it's called counting numbers. Right, moving on, another example. Let's say you are given set E containing the following elements: red, green colors, and blue. And you are given set R, and instead of roster form, I'm going to use a set builder form or set builder notation. And if you need help with this, you could check out my other episode on roster and set builder form. So let's say A, such that A is a color, belongs to a rainbow. Throwback to childhood, probably. So, and think back what colors a rainbow is made of, consists of. And there is a mnemonic acronym VIB, VIBGOR, that basically stands for violet, indigo, blue, green, yellow, orange, and red. So in set E we have red, which is basically here. We have green here, and we have blue. So we can conclude then that set E is a subset of a set R. So, and we could write it down. So E is a subset of a set R. Since these colors, they are in a rainbow, and these letters in this sequence of letters in this mnemonic acronym VIBGOR, I don't know how to read it, VIBGOR, which gives you that colors of a rainbow. Let me get into a proper subset quickly. Basically, it's denoted by just this side-weighted U, but there is no a small bar underneath. So the symbol for proper subset, it's very similar to a subset, just a normal subset, what we did before. The only difference is there is no little bar underneath. Sometimes, to emphasize the idea of proper subset, some books or some teachers use just that notation. This side-weighted U and the small underneath bar, they just kind of slash through, kind of cross it, slash through. Now, what does it mean? So, proper subset basically fits into two requirements. A has to be a subset of a set B. This is kind of the first requirement. And the second requirement, A is not equal to B. Well, it's a little bit confusing, I might admit. And the more practice, the more you do, the better you get. Let's have a look at some examples. Let's say you are given set A containing the elements A, B, C. And you are given set B is composed of A and B. Now, The elements of B, which are A and B, they are precisely in a set A. So we could conclude that B is a subset, is a normal subset of a set A. So, and we could just write it. So B is a subset of a set A. But also B and A, they are completely different sets. They are not equal to each other. So also in this sense, we could say that B is a proper subset of a set A. So you could look at this from kind of these perspectives of view. Now, if you take set A, B, C containing those elements A, B, C, and if you take set A, so you would say that this set is a subset of a set A, right? Because basically they're the same, it's the same set. But when it comes to proper subset, you cannot say that this set is a proper subset of A, because it's not a part, it's not like completely inside of set A. So it's a subset of A, but it's not a proper subset of A. Kind of a side note, notice that for any set A, A is going to be a subset of itself. It's always true for any set A. Why? Because A is basically equal to A. It's the same set. The second side note can be made based on the empty set, also a subset of any set A. One little remark over here. If you are given, let's say, set containing the elements X, Y, and Z, and you are given another set, let's say that set is made of the elements A, B, C, and D. So in this case, neither the first set or second set, they are not subset of each other. So in this case, we could write this symbol, which is taken to mean a symbol for a subset, and we can just put a slash through. So that means this set is not a subset. So is not a subset of that set. So the same goes for this set. So this set, and you could write it down, this set also is not a subset of this set. Also, if you look at this in terms of a proper subset, the same fact is true, it works for a proper subset as well, since those elements, they are not here, they are not present in that set, and the same goes for that set. So all of these elements, they are not present in that set. If it's still a little confusing to you, let's play a little round of this game. So fill in one of these symbols, or it could be two variations, let's see, to make these statements true. The first one, you are given a two element set containing elements 2, 6, and you are given this set containing 2, 8, 6, 8, 6, 10. So since 2 and 6, these two elements, they are here, so definitely the first set is a subset of the second set. So definitely a subset. On top of this, also, if it comes to a proper subset, you could also write this a strict symbol for a proper subset. It's also true. So either of these symbols are fine. Moving on. So since the first set is precisely the same thing as the second set, so the order just swapped, changed, so, and we could list elements of a set in any order you will. So it's basically the same set. So we would fill out, we will fill in with the equality sign. But also, if you look at this in terms with regard of subset, so it's gonna be also a subset, but not a proper subset, because they're basically equal. So either this symbol or that symbol is fine. Now, moving on. Multiples of 2, basically what they are 2, 4, 6, 8, 10, 12, list goes on. So all of these elements, they are present in this set. So definitely a subset. Definitely a subset. Also, it's a proper subset. Also a proper subset. So that symbol goes as well. Now, he, here, had. Okay. Since there is no the curly brackets, no braces, so it's gonna be either element or not element. So since this he is in that set, so basically this element belongs. It does belong to that set. So it's an element. So for a relation between an element and a set, we would use this Greek epsilon. So that indicates, that shows you the relationship between set and an element. And if you need help with this, you could check my intro to sets, where I came up with the idea of a set, of an element, of an empty set, and also I touched a little bit a subset as well. Moving on. It, and you are given the set which is made of the elements E, A, T, and ER. So it is not there. It's not present there. So you're gonna to write this symbol that indicates this relationship of a member and a set, and you're gonna to put a slash through, since this is a not element of that set. So that's not true, that's false. And finally, the last one, you are given the set that consists of the elements 1, 3, 5 and 7, and odd numbers that less than 1. So let's think a little bit. It's basically no numbers that less than 1, no odd numbers than less than 1, assuming we deal with a natural numbers. So this set basically is an empty set. So you would pick this symbol, since empty set is a subset of any sets. I hope it was helpful. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and make sure to subscribe so you will not miss out my new videos.